So we now have remotely Francesc Alted from the Blosc development team presenting on recent improvements they've been making to the HDF5 and Blosc2 plugin systems. So thank you, and you can take it away, Francesc.
Okay, thank you very much, David. Thanks for the invitation, for talking in such a nice venue. Yeah, so I'm going to talk about the recent improvements on the Blosc2 and HDF5 side of the things. So first of all, a few words about what is Blosc2. So Blosc2, it's the next generation of Blosc1, which is a well-known high-performance compressor, and HDF5 has support for it for many, many years already. So what is adding Blosc2? It's 63 bit containers that expands over the existing 31. So essentially what we have is a header here where the different applications can add meta information about the layers that they are adding. Then we have the regular chunks, and then these chunks are split again in different blocks. So instead of typical single partition schema, we have actually a two-layer partition schema inside of Blosc2. And then at the end, there is the trailer where the user can add variable length meta layers, up to 2 gigabytes of that. Also, Blosc2 is not the development of one single man. It's a multi-year, and a whole team has collaborated in providing Blosc2 functionality in the last years. So I am really proud to speak on behalf of this team today. Okay, so the agenda for today would be I will introduce you the new dynamic plugin system for Blosc2. Then a new plugin that we made for high throughput JPEG 2000. Then I will explain our support, or the support that we are working on for Blosc2 NDim inside HDF5. And I will say a few words about Btune, which is our artificial intelligence tool for automatic selection for the best codecs and filters inside Blosc. Okay, so let's start with the new dynamic plugin system for Blosc2. So how does it work? So,
I'm sorry, your screen sharing seems to have disappeared.
Oh, really? Okay. Can you, maybe I should stop sharing and sharing again, maybe?
Just wait a minute, something's happening in the auditorium.
Okay.
So I think so the thing is, yeah. Okay, so basically, here's the thing. Yeah, so I mean, is it being controlled here? No. It's okay, so sorry, it seems like someone is controlling a PC somewhere that controls what we see, but it's a bit of a mystery where exactly. So sorry, you're back on again. Excuse us for the interruption.
Okay, excellent. No problem. So yeah, as I was saying, we already implemented support for dynamic plugins. How does it work? So essentially what we have is the C block on the left. We have the Blosc2 library, which is written in C, of course. And whenever there is a need to load another codec, that Blosc, as you probably know, Blosc supports different codecs inside and also different filters. So whenever there is a need to load a new codec, and it is not inside of the library, what we are doing is to call DL open or load library in case of we are on Windows system, in order to open the DLL of the codec ID plugin that is on the system. And then we do the DLL is doing the compression and the decompression, whatever is the correct thing to do, and then it will provide the data to the original library. So we have a a post here explaining how these dynamic plugins work exactly, so that you can get a better feedback on that. So another interesting thing that we have done is that we are supporting, or we are distributing dynamic plugins as Python wheels. So let me explain why we think wheels are not only a great idea, but they are very well implemented as well. So Python wheels have a great backward compatibility with real old operating systems, which is great. And then they provide also a smooth user interface via pip for dealing with different platforms. So whenever you are on Windows, Mac, or Linux, all of this complexity is handled by pip. And wheels are mostly compatible with Conda environments. Actually, I normally mix wheels with Conda packages all the time without any trouble. So the Blosc development team is actively using wheels for distributing binary versions of these C plugins. So for example, OpenHDJ2K, as we will see later. And the idea is that anybody can create their own plugin.
I'm sorry, could you pause for a second? We have another problem in the auditorium with the screen lock coming on. So it seems that someone somewhere at DAISY is operating the PC that controls what we see in the auditorium, but I'm not sure if they're doing it remotely or whether they, I tried knocking on the control room there, but I didn't find anyone. So if the person somewhere at DAISY who was helping us can reveal themselves, that would be useful.
Mm-hmm.
Sorry, what was that? Yeah, so I guess, let's say I'll have a go here. No, this is displaying. Yeah, so we can give that a go, yes. We can see how that works. Sorry, some technical difficulties here. Yeah, well, the problem is here that what's shown on the screen isn't exactly what's plugged in. Yeah, so we can give it a try. I'll see, I'll try the show HDMI option, see if that makes any difference. The keyboard doesn't. It's a mystery, sorry. What was that? Yeah, yeah, I'll try again, yes. Could I check this to get the number of them? Sorry. 1444. Did it just... Francesc, can you hear us over Zoom?
Yes, I can.
Okay. Okay, so well, you're a genius, Andy. Thank you. So yeah, okay, great.
It is fixed already?
It seems to be fixed. Yeah, thank you.
Oh, wow. Excellent.
Yeah, okay.
Okay, so let me maybe accelerate a little bit. I will share my slides to you later on, so you can check that offline if you want to. Okay, so the idea, as I was saying, is that anybody can create their own plugins and distribute them in binary form, which I think it's a great service to the community. So some pros and cons for dynamic plugins. The pros is that they are very easy to install. So just do pip install, and the plugin that you are interested in. One advantage also is that we are not bloating the Blosc2 library with other plugin or other plugin manager like HDF5 plugin or new codecs or whatever. And this gives support not only for C, but also for C++, Rust plugins, whatever. The only requisite is that the plugins has to expose this C API for calling the primitives. And then maybe the only con is that it is a little bit more work to create wheels, but we are providing an example with detailed instructions here. And okay, maybe I am not sharing the whole screen. So, but in this link here, you can see very detailed instructions on how to do it. So yeah, this is about the new dynamic plugin interface for Blosc2. And then let me say a few words about the new plugin for high throughput JPEG 2000. So high throughput JPEG 2000, it's a new proposal that preserves almost all the rich features of JPEG 2000, except for quality scalability, for example, maybe. So we can see that here for encoding and for decoding. Let me check if I can use maybe some pointer here. Okay. Automatic. Yeah. So we can see that for encoding, this new codec can be up to 10 times faster for both for encoding and for decoding, whereas the quality doesn't suffer too much. So for example, PSNR here is like it's a metric for the quality of the image, and we can see that the quality it is not affected too much. You can find more information on the white paper here, and yeah. Today, I'm glad to introduce the Blosc2 Open HTJ2K dynamic plugin. It is using the corresponding Open HTJ2K, which is an open source implementation by Osamu Watanabe. So we already released version 0.1.2, so you can have a review, and you are encouraged to do so in case you are interested in this work, and it is packed and distributed already as a Python wheel, as I was describing. So you just have to do pip install Blosc2 Open HTJ2K, and then you are done. If you click here, you will see instructions, and there is a small tutorial on how to use it. So here there is an example of this new codec. It supports both lossless and lossy. And here is a difference between, on the left, there is a lossless image, and here it's on the right, it is a lossy compression image, where we can see that different artifacts are appearing due to lossy compression. But on the other hand, of course, the size of the image has been reduced quite a lot, to almost half of the original lossless version. So also, it will be interesting to see which is the effect of the block size on quality. As you know, Blosc supports what is called the second partition, which is called the blocks. And if we partition, if we use this second partition for splitting the original image, we can see that when we find the best compression ratio is when we match the block size with the image size. So it is this bar on the left side here, on the right side, sorry. And also for NCC, which is also a metric for quality, we can see also that we have the best quality when we match the image size with the block size. So that means that in general, OpenHT J2K works better when blocks are of the same size than images. We also are exposing all the parameters for OpenHT J2K in our plugin. Here there are some of these parameters, but there are more, and they are all supported. And also, this is still work in progress. So, for example, one of the things that it doesn't work yet is that this plugin cannot leverage Blosc2 multithreading yet, and this is because the underlying library is not threading safe. But still, we can use the internal one provided by the original project. But this is still work in progress, and we are in touch with the original author in order to try to see if that could be implemented soon. Then the support is only for Intel machines, for Intel platforms, although we agree that we know that having support for ARM64 should be interesting, especially for Mac users. And we would like also to make the Blosc2 plugin for HDF5 as well as HDF5 plugin aware of the many different parameters needed for OpenHT J2K. So as there are many of them, we should better be creative on how to pass them. So it would be nice to have conversations with users in order to get, for example, with good enough default values for the different parameters, or maybe try to pass the different parameters via environment variables in order to avoid cluttering the HDF5 plugin or the Blosc2 plugin with a too complex API. This is something to be solved. Okay, so let's move to the other section, which is the recent support that we are giving to Blosc2 NDim in PyTables and HDF5. So we recently brought a grant from NumFocus in order to provide this support. So, for example, for Blosc2, Blosc2 implements multi-dimensions for the different partitions. So here we have in yellow the original dataset, and here's a chunk for this dataset. And the addition of Blosc2 is that the chunk can be split on a second partition with also multidimensional blocks. Okay, so we have two different partitions, fully multidimensional, with fully multidimensional meaning. And you can see how does it work on the reference here. And that has nice implications because when one we can leverage the second partition in Blosc2 NDim in that, for example, for HDF5 or ZAR or others, as we only have one level of partition, whenever we want to get like a fine hyper slice, we are enforced to decompress, in this case, all these yellow boxes here on the left, on the right. Whereas with Blosc2 NDim, we can get much more selective and hence faster queries in retrieving all these hyper slices because we need to remove far less data. Sorry, to retrieve far less data, and that means more speed, of course. But in order to fully leverage the second partition inside Blosc2 NDim, we need to bypass the HDF5 pipeline. And for doing that, we are using the direct chunking capability that has been implemented in HDF5 several years ago. And the idea is to be able, HDF5 provides this capability of accessing the data inside of the file directly without going through all the HDF5 I/O pipeline. And this also is an opportunity to unleash the full I/O parallel capabilities in Blosc2. Here we have like a benchmark where we are retrieving different orthogonal slices. So for example, here we have like a three-dimensional representation of the slices that we are retrieving. So for example, in the upper part, we see that we are retrieving a slice with constant in dimension 0, with dimension 0 is constant, and then for dimension 1 and for dimension 2. And here we see that the speed, the throughput on retrieving these hyper slices in different dimensions here. And in blue, it's the PyTables Blosc2 filter, the regular filter through Blosc2. And then in red, we see the Blosc2 optimized. So the Blosc2 optimized part is the one that uses direct chunking in order to access the data. And we can see the acceleration without using any direct access and using direct access. We can see speed ups of more than 4 and 5 times. On green, we can see H5Py, which by default is faster than PyTables for doing hyperslicing, but still the new optimized hyperslicing capabilities are very good. And our plan is also to move these capabilities to H5Py in order to allow H5Py also to benefit from this work as well. Okay, so finally, let me say a few words about Btune, which is an automatic selection tool for the best codecs and filters in Blosc2. So Blosc2 supports many different parameters for doing compression. It supports different codecs, different filters, different number of threads, different compression levels, different block sizes, a lot of different parameters, right? And the goal for Btune is to fine-tune the different parameters of the underlying Blosc2 storage to perform as best as possible. So let me, probably I need to reshare the screen again because I want to, just a few minutes. I'm going to share the, so can you see my desktop now?
We see a full desktop at the moment.
Okay. Now, okay. So can you see the browser?
Yeah, we see the browser and this Btune example. Yeah, great. Good. So yeah, this is a diagram where the different so Btune it has like several states. So this is a representation of the different states. It's a state machine actually. So for the codec filter, shuffle size, number of threads, and when we play it, you can see that for every chunk that is being compressed, Btune automatically changes the different codecs and different filters, and then it provides an estimation for the score. Okay, so it annotates the different scores for different combinations, and it keeps track of the best score, right? So whenever it reaches convergence on the best score, it keeps using the one that has achieved the best score. Okay, so this is the
the most simple way to run Btune. This is mostly a genetic algorithm in that every parameter is tried on the fly. But we have different ways to run it. For example, instead of just the genetic algorithm that I have just shown you, we have the trained mode where the Blosc team train datasets for you, and that provides more accurate predictions for all the chunks. And this training happens using deep learning, right? So this is why we can get much better. So data is trained offline, so to say. And then there is a third tier of support where the people or community can use a fully managed version of Btune, which is called Btune Studio, where a group or a community can train data on their own. There will be a tutorial on Btune where I will explain all these different ways of working with Btune. And meanwhile, you can also get more information on the URL for Btune. So to conclude, Blosc2 is making rapid progress. We recently implemented a dynamic plugin support. We are very happy with it. And we will be also happy to exchange experiences with the HDF group. So in case they are interested in adopting similar strategies. We implemented a new plugin for high throughput JPEG 2000. Also, there is a new native support for Blosc2 NDim in HDF5, which is bypassing the HDF5 pipeline by using direct chunking. And finally, we are happy to announce that Btune is in production mode. So yeah, this is Blosc2, a highly efficient and flexible tool for compressing your data your way. So I also like to thank donors and contracts in every public speech, because without them, we couldn't have possibly put Blosc2 into production status. So thanks to all them, especially Lips Innovation, we joined recently to the contractors. And thank you for your attention. I would be happy to take any questions you may have.
So thanks very much, Francesc, and sorry again for the technical difficulties.
No problem. In the end, that worked pretty well.
Good. So do we have any questions from people? Yep, I'll give you the other microphone.
Hi, Francesc. Thanks for the good talk. I remember, if I'm not wrong, that you said the Blosc community guarantees the filters. You know, they're sort of future-proof. Is this true? And how do you do that?
Well, I mean, the future-proof. It's. I mean, we are as a team, we as a Blosc team, we are trying to strive with foolproof future, right? So this is very high in our standards, and actually, maybe I can show you how we responded. For example, so 5 years ago, for example, we introduced something that was making a backward incompatibility. And we took that happened 5 years ago, and I did a blog here on what the issue was for Blosc, and why we essentially did a wrong thing, how we reacted, and how we enforced a new forward compatibility policy. Okay, so whenever we are essentially what the new release procedure, we try to be very careful about introducing backward and forward compatibility issues, and we try to avoid that as much as possible. In case an accident happens and we introduce something that is preventing forward or backward compatibility, we are trying to react very, very quickly. So in this case, we took a couple of days to revert the situation and to provide this new policy. This is an example of our commitment for compatibility. Okay.
Thanks. I see we have another question over here. I'll need to be careful about that one.
Hi, Francesc. A technical question. I'm curious about details. So how are you controlling that the HD2000 JPEG plugin is multi-threaded or like single-threaded? Like you said, it's in some prototyping mode and it's environmental variables or some parameters?
Yeah, so that's a good question. Actually, we have a couple of ways to implementing multi-threading. One of them is using native Blosc2 multi-threading that is being used for many different codecs. The problem is that this OpenHT J2K implementation is not thread safe, so we cannot use this one for Blosc2, at least not yet. And also there is this problem with defining block sizes that are very small. So if the block sizes are very small, the quality of the compression ratio really suffers. So my gut feeling is that this codec is much better used when we describe when the size of the block inside Blosc2 is of the same size of the image. And in that case, it doesn't make sense to use Blosc2 multi-threading, because multi-threading works at block level, right? And the third thing that I would like to say is that there is a window of opportunity, because the original author for the library, Osamu Watanabe, he's also working on implementing an internal multi-threading thing. And there is a parameter that is already exposed in the Blosc driver, in the Blosc plugin, so that users can specify the number of threads. The problem is that currently this doesn't give you a lot of speed up, but I am in touch with him. He's interested in improving in that area. So we will see if we can get some improvements for doing multi-threading, at least using the internal multi-threading, which will not be affected by using very small block sizes.
Okay, thank you. That replies my question as well.
Thank you.
Thanks. So any other questions?
Hi, Francesc. It's Thomas Vincent. Thanks for the talk. I wanted to know if you had a policy to decide which filters, like compression filters, go into the core of Blosc2 and the one that you would leave outside as a dynamics plugin, like high throughput JPEG 2K that you just presented.
Yeah, that's a very good question, actually. So the idea behind having this new dynamic plugin capability is to avoid cluttering too much, to bloating too much data, or too much libraries inside of Blosc2. So I would say that our intention is to avoid as much as possible to bring new codecs inside of the library, and to promote users using the dynamic plugin approach, because this is a much more decoupled way to work. And I think it's in the long run, it is better, because the community would have a better sense of I don't know how to say, but property on their work, and they can be more responsible on updating for new versions, and don't wait for the Blosc team to include the new version inside of Blosc2. So we are hoping that with the new dynamic plugin capability, most of the people will be able to use dynamic plugins and be able to take responsibility on maintaining these dynamic plugins. Our own responsibility on that will be to assign an ID for people that wants the plugin to be used by the whole community, but it is up to them. We will be happy to include any plugin, or to register any new plugin that people, as we find it is as long it is solving some needs on the community, we will be happy to add in registration for that.
Hey, Francesc, this is John Reedy. I was curious for Btune. So I mentioned different compression filters. Some will compress better than others, but conversely, may take more time to compress or decompress. So how does Btune choose, the best filter based on this?
Exactly. So Btune has a parameter which is called I don't remember now, but it is like specifying how you balance for on one side the compression ratio and on one side the speed, right? And you provide a number between 0 and 1 and a floating point number, and depending on the value, for example, if you specify 0, that means that you are encouraging more the compression, the speed. And if you put this value to 1, you are saying to Btune that you are especially interested in compression ratio. And in between, you can have many different values, right? So you can specify your own interest in setting this variable, and Btune will manage to achieve that balance for you. That was the question. That answers the question.
Hi, Francesc, Jerome Kiefer speaking. I'd like to ask you how does Btune, the AI-powered stuff, do to manage the fact that different computer and different architecture will have different behavior regarding performances and maybe not compression rate, but performances as in terms of speed. How does it manage this?
Yeah, this is a very good question. Actually, we don't. It's so difficult to manage this. So, I mean, what we are suggesting to users is that we should really train on similar platforms that they are trying to use in production mode, right? So you are right. I mean, it's very different to train something on your laptop and to train something on a server. You can get much more different performance point, and compression ratios should be very the same, but performance should be really different. So yeah, I mean, our current approach is to suggest to use a similar platform that is going to be used in production in order to assess the performance as best as possible. That's how we are working on that.
Okay, thanks. I think are there any further questions? If not, then thank you very much again for speaking.
Thanks.
And so, yeah.
Thank you. Bye-bye.
Thanks.